Whether you're a student seeking a solid foundation in quadratic equations or an enthusiast eager to explore their applications, this video is tailored to meet your needs. With engaging visuals, relatable examples, and step-by-step explanations, we make learning quadratic equations a captivating and rewarding experience. Join us on this exhilarating journey of mastering quadratic equations, unleash the power of parabolas, unlock real-world problem-solving skills, and elevate your mathematical prowess. Request a tutor now, link found below, to embark on a remarkable adventure of mathematics exploration. Now, quadratic equations. Quadratic equations are algebraic equations that involve variables raised to the power of 2. The general form of a quadratic equation is a. X squared plus bx plus c equals 0. Here, x represents the variable, while a, b, and c are constants, where a is non-zero. The goal when working with quadratic equations is to find the values of x that satisfy the equation. Key elements of quadratic equations. Coefficients. A is the coefficient of the quadratic term, x squared. B is the coefficient of the linear term, x. C is the constant term. Discriminant. The discriminant, denoted as delta, is a mathematical expression within the quadratic formula. It is calculated as delta equals b squared minus 4ac and helps determine the nature and number of solutions. Quadratic equations typically have two solutions, known as roots, which may be real or complex numbers. The solutions can be found using the quadratic formula x equals negative b plus or minus square root delta, divided by 2a. If the discriminant delta is 0, the equation has two distinct real solutions. If delta equals 0, the equation has one real solution, the roots are equal. If delta is 0, the equation has two complex solutions, the roots are complex conjugates. Graphically, quadratic equations represent a parabolic curve when plotted on a coordinate plane. The vertex of the parabola can be found using the formula x equals negative b divided by 2a, which gives the x-coordinate of the vertex. The y-coordinate can then be obtained by substituting the x value into the equation. Quadratic equations have various applications in science, engineering, and real-world problem-solving. They are used to model and analyze situations involving projectile motion, optimization, geometry, and more. Solving quadratic equations is crucial for understanding higher-level concepts in mathematics, such as complex numbers, factoring, completing the square, and the quadratic formula. These methods help find solutions even when the equations are not in standard form.